Okay, so does increasing carbon dioxide increase the greenhouse effect? The answer is yes. Okay, I don't have time to go into this, but you can ask the question, is the extra carbon dioxide enough to explain the temperature rise? In some ways, the answer is no. Okay, it's about half what you need to explain the temperature rise. And so what we think and what the models say is happening is you have feedback effects that amplify that and give you the other half, okay? And by the way, I have to call out Ada Lovelace here, Byron's daughter, because she was the first person to actually envisage numerical modelling, and extraordinary, extraordinary feat, absolutely incredible. When Turing found out that he was following in her footsteps, he was staggered that she'd actually been able to work it out. What we know about models is this: there is a saying, garbage in, garbage out. If something's wrong with the model, your answer will be wrong. Okay? So you've got to be careful. It's always true, that. So what you have to do is actually look at all the models and all the runs of all the models and take them all seriously. You mustn't cherry pick the ones you like. Okay? You must actually look at the whole thing. Okay, let me answer a few more questions. I could go on about that, but I'm not going to. Okay. Is irradiance, solar radiance, the cause? I've already said I don't think it can change much, but actually we know it's not the cause. These are maps of temperature change over a 20-year period, and what you've got here is latitude and pressure, and therefore height in the vertical scale. What you're seeing in red is the warming of the troposphere. This is satellite data. And in blue, you're seeing the cooling of the stratosphere. Okay? That is a unique signature of a greenhouse effect. What you're doing is you're trapping in heat, and so the upper layers are cooling because they're getting less heat. Okay? If it were an irradiance factor, this would have warmed as well as the troposphere. Okay? So we know categorically that it's not caused by irradiance changes. I think you'd agree with that, wouldn't you, Henrik? Yes, good man. I picked a moment where I knew you'd agree. Okay, right. So no. Okay. Why don't I think that other solar magnetic influences could be a factor? Okay, here is a good indicator of solar magnetic activity, the sunspot number. And notice the last cycle that we're just coming to an end of now, cycle 24, was pretty puny. And it's rather similar to one we saw between 1900 and 1910, cycle 14. And then this is my contribution to the whole thing. This is the magnetic flux leaving the sun. These are measurements here in blue, and the purple is a reconstruction based on geomagnetic activity data. And again, you can see cycle 14 and cycle 24 are pretty similar. This is the cosmic ray flux. The dots are directly measured by neutron monitors. The purple is a reconstruction based on paleo cosmogenic isotopes in ice sheets and tree trunks. And again, you see cycle 24 is quite like cycle 14. And yet the temperatures in cycle 14 were way lower than we've had over the last year. And in fact, I heard on the radio on the way up that they think that this decade is going to be the hottest decade we've ever known. Okay, since records began, as they say. So for me, that's why I don't think solar activity is a factor on a global phase. But I don't want to throw the baby out with the bathwater. There are things like this. Okay, these are, this is El Nino effects globally. This is a correlation between the temperature at that point and the input. And El Nino obviously warms up the Pacific. This is aerosols from volcanic eruptions. This is man-made effects. And this is the influence of solar activity. And for some reason, Eurasia is particularly prone to, has particularly strong. And I've looked at this, and I think it's a winter effect. It's European winters seem to show a solar influence effect. So I'm not ruling out solar activity effects at all. I believe that they're there. I look for them. But I just don't think they operate on a global scale. How long have I got?
2 minutes.
OK, quick. I just wanted to say a little bit about temperature reconstructions, because these are put together from an enormous, it's not just tree rings or ice sheets, there's an enormous amount of material goes in here. And these have all been put together, and I'll just show you the result. This black line here is the most likely value, the mode of the distribution, and the colours give you the uncertainty, the spread of the distribution. You can see as you go back in time, it gets worse. Okay? And then the blue dots are the measured temperature record. And people talk about this dip in the middle being the little ice age. Okay? I hate that term because people make up scientific arguments that are pseudo-scientific. They're semantic arguments based on the words little ice age. Okay, it only lasted 250 years and it was only about half a degree deep. Both of those are nothing like a full ice age. Okay? And in this country, we have a temperature record that is actually the longest in the world. It's called the Central England temperature. It goes back to 1660. It's measured in a triangle in rural areas, so there's no urban or heat islands to worry about, between London, in the main, between London, Lancaster and Bristol. Okay? And here's that reconstructed temperatures, and here's the temperature record. And then you look at the temperature in central England, and you just see how variable it is from year to year. It's really hard to see a trend, although these are the winter months and these are the summer months. And actually, if you look closely, you're just starting to see a warming effect in that warmer winters and warmer summers are becoming more common. Okay? But I want to just look at this year here. Now, this was 1763, I think, or 64. It's the coldest winter in the record. It was cold all over Europe. There was a frost fair. Incidentally, frost fairs have got nothing to do with climate change. They're all to do with the flow of the River Thames. And anyway, we won't go into that. And that's the coldest in the whole record. Look at this. The next winter was the third warmest in the whole record. The idea that it's a little ice age, it was constantly cold during the Maunder minimum, it's nonsense. It just isn't supported by the data. And when you look at the summer, you actually notice that the cold summers are actually caused by volcanic eruptions. Okay? That's what does our summers in. Okay? So for me, there's interesting things. Oh, by the way, oh no, I've lost the plot. Too late, I'll carry on. Okay, I just wanted to...
2 minutes.
Yeah, 2 minutes again. Okay, it really will be 2 minutes. I just wanted to say something about modern measurement techniques because this is a wonderful mission. This thing that looks like 2 chicken huts with solar panels on the top. It's called GRACE, Gravity and Climate Explorer. They're about 200 kilometres apart and they measure that separation incredibly accurately. And the reason it works is that if you fly over something massive like a mountain, the near one gets accelerated first, and then you reach this situation where the mountain's pulling that one back and that one forward, and then you return to normal. And as a way of measuring the mass of a mountain, it's rubbish, but it's very, very good comparing orbit to orbit, seeing the changes. Look at this. This is the weight of the soil in the Amazon, because in winter, it's wetter, okay? And then it dries out in the summer. So you can actually tell how wet the soil in the Amazon is from the gravitational pull, okay? What's that got to do with climate? Well, to start with, it tells you for an absolute certainty we're losing the ice sheets, okay? Not just in area, not even in volume, but in mass. Mass of water is disappearing. Okay? There isn't any scientific doubt about it. Are sea levels rising? Okay, well, this early stuff is tide gauge data, and that's really difficult to use. But this isn't one black line, it's actually about 20. They're raised from altimeters on satellites, and they all agree, and you can see sea levels are rising. And from GRACE, we can even tell that actually about 2/3 of that rise is caused by melting ice from the ice sheets, and about 1/3 is because the oceans are warming. And notice how well the altimeter data and the GRACE data marry up. So this is the sort of precision and information that's going into modern climate change. It's not just a bunch of thermometers around the world. Okay, I need to stop. I'm not going to let that go through all that. I should just say thank you for listening and hand over to Henrik.